Here we go. Yes. Can everybody see that?
Yeah, we can see it.
Excellent. Yeah, hi. I am Jakob Portekrans. I'm going to talk about Khronos and its open standards. I'm going to first talk about who I am and then what is Khronos and sort of a quick overview of the APIs, list some of the important ones, and then have some recommendations. If you just give me a moment. There we go. And now we should be able to see me as well. So let's see. Yeah. Who am I? As I said, I'm Jakob Portekrans. Here's basically all my contact information if you're interested. Some background on me, so to fill you in sort of where I'm coming from. I have a background in free and open source software, and I'm very much, I would say, a proponent for free and open source software. I'm also a programmer / engineer, which means if you ask me questions, I'm probably going to answer you as a programmer / engineer. So problem solving, things like that is my thing. And I work for Collabora, which is a open source software consultancy, and we specialize in Linux and graphics and those type of things. I have a background in writing actual graphics drivers, mostly for Linux, but a little bit on Windows as well. I used to work for VMware for a while, so I have knowledge of virtual machines. I also worked a little bit on Qemo, and I have been part of several Khronos working groups as well. So what is Khronos? As they said, it's a open source it's a consortium that builds open standards. I would say it's a symptom of the current IP climate, I would say. I see it almost as a necessary evil, but at least it allows us to do open standards that we can work together. It's also a legal framework where we basically all the companies that are participating in it sign an NDA and also promise not to sue each other if we do, if we implement the APIs. And it also, that legal framework allows the engineers to work together to actually solve the problems, and they have to be a lot less careful to not tiptoeing around and not being able to be more direct and actually solve issues with that together. There are a whole bunch of standards that different Khronos working group does, and not everybody, not all companies does all of them. So, and different groups are, have different members or different size and things like that. There's, these are the open active standards, and I will sort of quickly go through them. I won't actually list all of them. I will basically categorize them, so you can sort of, if you see them, you will then know a little bit how this is, and then sort of see where it all fits together. The biggest group of this is graphics. There's a whole bunch of them. Some of them do various different things. There's a 2D API for vector graphics. There are embedded versions. There are web versions. There are people have probably heard of Vulkan. There's Spear, which is the actual standard for the shading languages. There's the OpenGL self-critical, which is what actually goes into airplane instrumentation. So that's basically why there's a special one for safety criticals. Then there's those standards that focus on compute, AI, and vision. Those are probably not something you will be very much interested in. maybe there's some like machine learning stuff that an artist would want to do to sort of do it for a artwork, and you might come into them then. But yeah. The one you're probably running most is the graphical formats, which are actually not a API that you program to. It's actually file format description. This includes DLTF, which I was talked about before, Collada, which is a older format that's not that popular. There's also a new working group called 3D Commerce, which is more about making objects look the same in all the stores. And like IKEA joined this, and they want to make sure that their highly detailed models of their furniture looks the same in all renderers and things like that. So that's why they sort of did this. So maybe you will run into that further down the line. We'll see. And then there's the fourth and last one, which is sort of where I'm mostly from, which is the virtual and augmented reality one. There's only one, and it's OpenXR. So I'm gonna, So talking about the important ones, or at least that I feel the important ones, are the ones that you should probably know more about. OpenGL, which is basically sort of the first Khronos standard, even though it's not made, I mean, when it was made, Khronos wasn't even around, so that was sort of formed afterwards. It was released in 1992, and application written against that version of the API can still be run, and that's 27 years of still working. The actual applications probably won't work because they were written for the rest of the system that they were written for isn't around anymore. So you probably still have to modify them, but the core graphical API from that, you can still do it. It has been greatly extended and changed from that, but there's still like a compatibility profile for OpenGL, and you can still run those programs, which is great. It's probably what you want. Follow up on that is Vulkan, which was released much more recently. It has a wide availability, basically all of the interesting platform except Apple, which is annoying. There's an emulation layer available called Molten VK for Apple platforms. Mostly, I don't think artists will actually be using Vulkan directly. There was something like hidden behind Unreal and Unity and those engine frameworks will probably be talking to it, and the artists will use the engine's own APIs. But yeah. Then there's OpenXR, which is the newest API. It is out now, and as they said before, we released it on SIGGRAPH last year. Version 1 we're focusing mostly on getting VR right, and then adding more extension and extending the API for AR interactions. Currently there are not that many implementations out there, but Oculus even has shipped a preview of it, or are shipping in the next version of their Quest SDK. They're shipping a preview of it, and we Collabora is making a completely open source runtime version of this as well. Currently we are talking Linux, but we want to be able to run everywhere and let people port it everywhere. So we want to support as much hardware as possible. And finally, the one I wanted to take up is the one I know the least amount of, which is the LTF. And to me, it seems to have won. For me, I think that's the only format of the open formats that people seem to be using and it's both for online and offline. It had a start in the web. I think it was started out as web model transfer layer or something called, and then changed name to GLTF, named after OpenGL. They also work on standardizing the renderers, so you can compare renderers and make sure that a model is the same on, if you run it in a browser, if you run it in an offline renderer or things like that, they look the same, or even just different web frameworks for rendering them. And there's wide support, and it seems to be, all of the big guys are on board with that. So for recommendations, something that you can do is not just talk to artists, but also talk to engine vendors and platform providers. So talk to Microsoft or Apple and say, hey, you should support these open standards, or it's good, or you congratulate them or things like that. But also, shame them if you can, make them realize that they are the baddies, so to say. And I have very much on purpose put the Apple icon there for a reason. And yeah, actually make them see that it actually either in goodwill or actual financial thing, make them hurt their bottom line, because otherwise they are just gonna keep going, doing the stupid things that will make life hard for you. It's the sad truth of the thing that's what really matters. It's the bottom line. Even though you can talk to like a person, like a worker there, it's very hard for them to convince the upper management if all the thing that the upper management see is the bottom line, because that's usually what they are focusing on. So when it comes to actual technical recommendations, get artists to export their games from, say, Unreal or Unity, in like making them use Vulkan OpenGL, because then you can emulate the other APIs much more easier. There are, as they mentioned, the Wine project, where it can emulate DirectX, but it's not as good as if they were just using OpenGL or Vulkan directly, especially since there are native drivers. So if you want to say run, a solution might actually be to just take the artwork and run it on Linux instead of Windows, and have much more greater control of the platform and using Vine. And then if you don't have to emulate DirectX, that just makes your life so much easier. And yeah, once OpenXR is available, I use that, because then you will have a lot better cross platform or even cross hardware compatibility. You don't, the API is specifically designed to handle different types of hardware, and make sure that they try to minimize the use of platform-specific APIs, which is important because a lot of the features that artists might want, especially in the AR and those type of things, interactions, are not available in, say, OpenXR yet. So yeah, but try to minimize that, because then again, it's easier to emulate that thing, and you're probably not that dependent on a lot of weird things that might be in the actual operating system. So I'm sorry if I shoot through all the slides, but do people have any questions?
Thanks so much, Jacob. I think everybody is probably thinking that you're going to save us all. 3 years, that would be great. We'll be all right.
Yep.
I was wondering, were you involved in the Open HMD project?
Yes, I was way back.
And I thought something that was really interesting about that was the reverse engineering of like
Mhm.
VR headsets that you did as part of that project. I wondered if you could like kind of speak a little bit about what it seems like you did have an absence of some open standards and you were sort of forced to reverse engineer something. Could you talk a little bit about that?
So unfortunately, open standard doesn't really help us that much there. So I mean, if you don't want to run, so from my perspective, like we want to avoid using closed source software. Period. And we just want to do open source software, and all of the runtimes are closed software. So we have to figure out how to talk to the hardware and make it work on our own. So we need to replace the entire stack basically. So that's sort of the driving factor there. And also say, hey, we want to be able to reduce Oculus hardware on Linux, and they currently aren't shipping any drivers or runtimes for there, so you can't actually use it on Linux. So that's sort of our motivation there, and we're still doing it for all of the hardware. So we're currently looking into providing open source drivers for the Vive, for the PSVR, and all those hardware. And a lot of there's talking to the hardware is probably the easiest part of the reverse engineering. It's all of the math and figuring out. So there's lens distortion and things like that that's not documented anyway. That's hidden in the runtimes. So those are the problems that we have faced there. So yeah, so we're just figuring out how to talk to them, talk to the hardware, and then all of the physical aspects of the hardware, and all of the math that involves in tracking.
Can you give us an idea of like how labor intensive it is to like figure out like lens distortion mathematics or something?
The easiest is you just stick a very calibrated camera into the lens and then display a pattern on the hardware, and you see how it's changed. And that's basically how you do it, and you create a profile on there. But we have some code to do that, but we're not really there yet to have that as automated as we probably like. So right now we're just taking an image of a pattern and then by hand changing the formula and to make it undistorted, basically.
Is OpenHMD still under development? Sorry if you already said that.
No, yes. So we started a project called Monado, which is basically OpenHMD version 2, which implements OpenXR. So yeah, so we're still doing that.
Okay, cool. I mean, I've got a whole load of questions, but I'm keen to make sure others get an opportunity as well. So if anyone wants to ask something, just go ahead or type in the chat. And one of mine is probably a bit of an annoying question, but I was wondering what the likelihood, if you could comment on the likelihood of Khronos maintaining backwards compatibility in OpenXR. So will we be able to run our old OpenXR apps on newer versions?
Yes, definitely. That's definitely one of the things we want. And I mean, so there's, how do I put this? There's strict rules around what we can, deprecate and how to do it. But all applications, as long as there's a version 1 out there, version 1 applications will run. It's the intended cause, and it's more up to what the runtime vendors will support. So say if we in 5 years release a version 2 of OpenXR, the runtime vendors will probably support version 1 for another 10 years or for however long it's for feasible for them. But say the open source community will probably support that forever, because there's always going to be some person who has this hardware or this application that they want to run that's written for version 1.
Okay.
And then, if you find that some of your application isn't working, then you can, since there is open source runtime, then you can actually fix it yourself. So you're not at the behest of whatever runtime vendors want to support.
So if someone was faced with an Unreal Engine project or something with software that had been built for VR software that had been built for Windows in the past, say, how straightforward would that process of moving it to a fully open source stack be? So Linux and everything on top.
Depends on if you have the source files, if you if you have those source files, and if you can upgrade to the latest version of the engine. So Linux support isn't available right now in Unreal, and we're hoping to solve this year, so that there's Linux VR support, OpenXR support. So we're hoping to do that fairly soon, and then it will be available to all, artworks that have using Unreal engines from this point on. So then it should definitely be easy. Hopefully, as long as, again, per my recommendation, don't use any other platform APIs. If you actually have just the binary or the basically export artwork, then it might be harder, and then you're basically at the behest of Wine. And again, per my recommendations, if that application is just use that exported binaries using OpenXR, even if it's the Windows version, we can probably plug in our API directly there, and it should work pretty well, hopefully. So then it becomes a lot easier. But if you also have to emulate, say, OpenVR or the Oculus API, then it's more work. And right now, I don't know if there's any projects for that. There might be in the future that actually try to emulate OpenVR on OpenXR. So we'll see.
Thanks.